Welcome to 8.1 Trigonometric Exploration. So we've already talked about trigonometric functions. However, today I want to talk about all the stuff that you can do with those functions, right? So we want to continue our study of triangles, and we're going to be looking at two specific types of triangles. This triangle is the isosceles right triangle, or it could also be called the 45, 90 triangle, because that's two 45-degree angles and one 90-degree angle, right? Triangle or isosceles, so the angle is 45 degrees. So one of if we set one of the angles to be theta from our anagram and whatever mnemonic SOHCAHTOA, right? We can find out that sine is opposite over hypotenuse, which is x over x square root of 2, which is 1 over square root of 2, which is you normally see it as square root of 2 over 2. And I'll tell you an easy way to memorize some of these maybe in the next lesson, right? Cosine is the exact same. Because guess what? Cosine is also x over x square root of 2, which is also 1 over square root of 2, which is also square root of 2 over 2. Right? However, tangent is 1 because, well, tangent's opposite over adjacent. Opposite over adjacent is x over x, which is just 1. Right? So we know our angles for 45 degrees. Now we're going to go our angles for 60 degrees. Right? We want to know what a 30, 60, 90 triangle will look like. Right? So we know that this is we have an equilateral triangle, right? So we have our equilateral triangle right here. I'm going to draw one right here. This is 2x. They're all sides 2x, right? And this is all they're all angle, and all the angles are 60 degrees. 60, 60, 60. So if we split this in half, what are these angles? Well, these angles are 30 degrees. 30, 30. And then these angles are, well, the angles that we want to observe, which are right angles, right? 90 degrees. So if we put theta, if we put our theta right here, right? Let's put our theta right here. So sine of theta right here is sine of 30 degrees, right? Sine of 30 degrees, which is x over 2x, which comes out to be a nice number, 1/2. Cosine of this theta will be adjacent over hypotenuse. I'm gonna write it out. Right, would be x square root of 3 over 2x, which is what, square root of 3 over 2. It looks a little messy, but it's really nice whenever you have those long, complicated formulas, and then you can simplify it down to a simple formula like this. Right, so tan 30 is x over x squared root of 3, which is 1 over the square root of 3, which is square root of 3 over 3. Right? It is not that hard to understand. So sine 60, right? This is, I've left this blank intentionally. So this is, let's say this is the blue theta. So sine 60, this is 60 degrees, right? 60 degrees. No, I just wrote 60 to the 6th power. 60 degrees. So we have sine 60 is opposite over hypotenuse. Opposite x squared root of 3 over 2x. So what's, I'm gonna write in blue. X squared root of 3 over 2x is equal to square root of 3 over 2, because you can just cancel the x, right? Cancel the x. So cosine of 60 is adjacent over hypotenuse, which is x over 2x. X over 2x. And that is 1/2. And tangent of 60, opposite over adjacent. Opposite over adjacent is x squared of 3 over x. Which, if you cross out the x's, that leaves square root of 3. And that is it for all the triangles. That is it for the special angles, right? The 30, 60, and 45 degrees. And you should remember those. And I will tell you a strategy of how to remember those later. However, this is possibly the most important thing you'll ever learn whenever you're dealing with trigonometric functions, is some of this fact, right? This fact is you draw a circle, or you draw this circle of x squared plus y squared equals 1, and if we have our triangle, if we put any triangle, right, like the triangle can be like this, right? If we put it like this is angle theta, right? This angle is angle theta. However, our right triangle is actually working from here, right? And then we can tell our angle, our position based on that. The x and y coordinate of whatever angle theta is sine x and cosine x accordingly, right? So sine x, sine theta, and cosine theta is equal to the x and y coordinates. Well, no, it's with the y and x coordinates. Y, comma x, right? Sine theta is y and cosine theta is x. Because here, if you look at sine theta right here, that's opposite over hypotenuse. What's opposite? Opposite is the opposite is y. And what's the hypotenuse? The hypotenuse is the radius of the circle, which is 1. So it's y. Cosine, opposite over hypotenuse, adjacent over hypotenuse, I mean, which is x. Tangent is y over x, which I guess I can tell you why it's like this, but I'm not going to tell you right now, maybe later. Right? So the important thing that you can deduce from this is for all sine values, you can find a corresponding cosine value. So for example, with this identity right here, so this is theta, this is 90 minus theta, right? You could tell that sine theta is equal to cosine 90 minus theta, because right here, if you have theta right here, opposite over hypotenuse, and cosine theta right here, cosine 90 minus theta, this is 90 minus theta, the angle, which is adjacent over hypotenuse. It has the exact same configuration, right? So sine theta is equal to cosine 90 minus theta. So if I would ask you to find the cosine of sine 22, you will be able to say cosine 68 instantly, right? And that can be really useful in simplifying equations later on. But you can also find a corresponding, you can also deduce that sine squared theta plus cosine squared theta is 1. Why? Because what? Pythagoras' theorem, Pythagorean theorem, right? We have our radius, which is 1. We have our x, which is cosine theta, and then we have our y, which is sine theta. So if we square this, and if we square this, and if we square this, oh god, I'm sorry, that was really bad squaring. You'll get the exact same thing, right? Sine squared theta. So sine squared theta plus cosine squared theta is equal to 1. Really interesting fact. We're going to do some proofs right now. We're going to do some proofs right now. So practice problems. So if the value of sine squared theta is 0.3, what is the value of cosine squared theta? Well, that's easy, because 0.3 plus cosine squared theta, I should write the whole COS, because c squared can be a little bit confusing. Cosine squared theta is equal to 1. So cosine squared theta is equal to 7. So no, 0.7. And then cosine theta, cosine squared theta, this is just funny notation. It actually means cosine of theta, the whole squared, right? So the whole thing, the whole cosine of theta squared, right? It doesn't want to, you don't want to confuse it with cosine of theta squared, because that's a totally different thing, right? Cosine of theta squared is different from cosine squared of theta, right? That's why, because some students, they write this cosine of theta squared, which is totally fine. But if you write cosine of theta squared, that is not fine, because it means a totally different thing, right? So cosine is just square root of 0.7. What is theta? What is theta? Well, we can do the undoing of by doing the inverse of the function. So we have cosine inverse of the square root of 0.7, which I will do it on my calculator right now. I think it's about like 20 degrees, maybe less. Okay, 0.7 square root, right? I don't even think there's inverse. Let's say it's about 15 degrees, right? 15 degrees. So if we have tan x is equal to sine x minus cosine x, which is true, right? I should tell you to prove this. I will tell you to prove it later. But tan x is equal to sine theta. Tan theta equals sine theta plus over cosine theta. Right, tan squared theta only in terms of cosines. So if we square this whole function, we'll get tan squared theta. Tan squared theta, if we square this whole equation, right, is equal to, well, sine theta over cosine theta, so everything gets squared. Sine squared theta over cosine squared theta. But we gotta write everything in terms of cosines. So if you see this function right here, you can notice that we can actually subtract sine squared theta on both sides. So we get sine squared theta, like this. So cosine squared theta is equal to 1 minus sine squared theta. But that's basically leaving it in terms of signs. So we'll just we'll subtract cosine squared theta on both sides, and then we'll get sine squared theta is equal to 1 minus cosine squared theta. So this is just equal to 1 minus cosine squared theta over cosine squared theta. And that is the answer. Okay. If the value of cosine is 0, what is the corresponding degree on the unit circle? And what value of sine theta? Well, if the value of cosine, okay, let's go back to your unit circle. If the value of cosine theta is 0, cosine theta is x, right? So when x is equal to 0, it's basically this line right here, right? So when the value of cosine theta is 0, x is equal to 0, right? It's equal to 0. And when it's equal to 0, it can be cosine can be theta can be 90 degrees exactly. Look, 90 degrees exactly. See, we have our theta can be our 90 degrees exactly, or it can also be. Okay, I'm really sorry about that. Anyways, we have our unit circle. Our cosine is 90 degrees. Our theta is 90 degrees, and our sine is actually 1, right? Because cosine squared is cosine 0, so cosine squared is 0. So sine squared is 1. So sine is 1, right? Sine theta is 1. And you could see, obviously, that the y value, y is also 1, right? So prove that there's 2 possible values of sine theta for each value of cosine theta, and vice versa, except in certain cases, right? So except in certain cases. How is there 2 possible values? Let's go back to the unit circle, right? There are 2 possible values of sine theta for every value of cosine theta. This is probably not like the bestly worded question, like how I just spoke right there, but it's 2 possible thetas of sine theta. Basically, there's prove that there's 2 possible angles that theta can be So we can prove that, right? So cosine belongs to the x. Since cosine belongs to the x, we can draw a line down. How many points does it cross? That x line crosses it at 1 and crosses it at 2 points. Right there. That's it. The proof is done. Right? Every line that I draw down, it crosses at 2 points, except the tangent line right here and the tangent line right here. Otherwise, it crosses at 2 points, and that's why this is the case, right? So this is more like a show question. Prove that tan theta is equal to the square root of sec squared theta minus 1, given that sec theta is equal to 1 over cosine theta. I already gave you this, right? So we'll start, right? So we want to get rid of the square root. That's pretty much like the most logical thing. We'll square both sides. So our squaring both sides will get tan squared theta is equal to square root of sec, no, is equal to just regular sec squared theta minus 1, right? And then we can decompose it, we can make this turn into, no, we can decompose this into sines and cosines. So tan of theta is just sine squared of theta over cosine squared of theta. And that's equal to, well, this is 1 squared minus cosine squared of theta minus 1, right? And since our 1 is independent, we can just have the same thing on both the numerator and the denominator, and it will still be the exact same thing. So we can change our 1 into cosine squared of theta over cosine squared of theta, and then we can copy this. This. No, oh my god. Okay, this is really annoying. I'm gonna have to rewrite it. So sine squared of theta over cosine squared of theta is equal to 1 minus cosine squared of theta over cosine squared of theta. The reason why we can just combine them is because, well, that's cosine squared of theta. They're both under cosine squared of theta, right? And we've established that sine squared of theta is equal to 1 minus cosine squared of theta. So replace this sine squared of theta, and we are done. The proof is done. Normally when we do proofs like this, I normally do not advise you to change both sides, and that's normally what teachers will not like. The teachers don't like you to change both sides, but if you have to, you should, right? So that's gonna be it for today's episode. If you liked it, press the like button. I need to be doing more math lately. I know all the videos I've been pushing out is just chemistry. I need also to be doing Nihongo, but I'm really busy with the summer study that I need to go to the next grade level with the classes I want to take. So please understand that, right? And 20 minutes of vanilla Minecraft for my other channel, I will post that probably tomorrow. And that's it. That's all the announcements I have. So I'll see you next time.